Lesson 3.1, Graphing Linear Equations. Our essential question today is how do you determine if an equation represents a linear or nonlinear graph? The word that I want you to focus on in that essential question first is equation. So when you answer this question, make sure that you are answering it based on looking at an equation and how you can determine if an equation represents a linear or nonlinear graph. To get to that point where you can look at just the equation and not look at the graph, we are going to do some graphing. The word linear, our first vocab word is the word linear. If you look at the first four letters in the word linear, they spell line. So if something is linear, its graph is a line. If something is nonlinear, the prefix non means not, so the graph is not a line. Now, nonlinear graphs, something that is not a line. I'm going to draw a couple of sketches for you. Something that is a line could be diagonal, could be horizontal or vertical. Something that is not a line might have a curve to it, like that. Might have a curve like this. Or it might look like it's a line, or a combination of a couple lines, but it's not. So if it's straight like my third nonlinear graph, if it has two pieces, like two rays, that's not going to be a line. That's not going to be a line. So line just means one line. The entire graph is one line. That's linear, not just a part of it being linear. Okay, so what we're going to do is, you have a worksheet for your homework today, and I've got a slide that goes with every problem that's on your worksheet. So I'm going to pick out a few to do together with you, and then the rest of them you will have to fill out on your own. In order to graph all of these equations, we're going to make a T-chart table, Our x value is our independent variable. So we get to choose that variable. We get to choose the value that we plug in for it. And then the dependent variable is y, because y depends on the value that we substitute for x. So I'm typically going to go with the values 2, 1, 0, -1, and -2. Those are like my favorite 5 values to plug in because they're not really big. So they usually fit on our coordinate plane nicely. Not always, though. Now, I'm going to plug them in. So my equation says that y is equal to 3x minus 1. So where the variable x is, I'm first plugging in my 2. So 3 times 2 minus 1. You have to make sure you're following the order of operations here. 3 times 2 is 6. 6 minus 1 is 5. So now that ordered pair is 2, 5, which you would graph right here on my coordinate plane. The next independent value is 1, so 3 times 1 minus 1, or 3 minus 1, is 2. So when x is 1, y is 2. Next is 0. Anything times 0 is 0. 0 minus 1 is -1. So when x is 0, y is -1. So I'm just going to keep going with my 5 values. So -1 is -4. And my last one, -2, is -7. So looking at these points, I connect them, I get a line. So, is it linear or nonlinear? I am going to say this one is linear because my graph is a line. And is it a function? Is it a function? Remember that to be a function, it had to pass the vertical line test. So if I draw vertical lines through my graph, yes, it also passes the vertical line test. So it's a linear function. So that is what we're doing in our lesson today. We're making a table. We're selecting 5 values of our independent variable x. We are plugging them in one at a time to solve for the dependent variable y. We're graphing, and we're determining if our graph is a line, and we're determining if our graph is a function. Okay, so the next one on your worksheet should look like this. I'm going to go with my favorite values again. So if I plug in 2, look at how I plug it in. Remember that when you do PEMDAS, you have to do parentheses and then exponents. So on this problem, I actually have to do the 2 squared, which is 4, and then multiply, which is 8. So 8 minus 4 is 4. So 2, 4 would be my first point. Plug in the next one, just like that. Just make sure that you follow the order of operations, and you should be able to finish this problem. The next one, x. Four over x. I think that matches your worksheet now. On this one, what I want you to think about is, on the bottom of the fraction, you're dividing by your x value. So my independent variable, I just want to make sure that I really think about the numbers that I put in to make sure that they're divisible by 4. So on this one, I'm going to do a little bit different numbers because 4 divided by 4 would be good. 4 divided by 2, 4 divided by 1. You cannot divide by 0. You cannot divide by 0. That's undefined. I could divide by -1, -2, and -4 though. So that will give you some better results. What happens when you plug these in on this one? You might get a shape that you're unfamiliar with. So I want to show you what happens on this. If I plug in 4 for x, I get 1. If I plug in 2, I get 2. If I plug in 1, I get 4. -1 is -4. -2 is -2. And -4 is -1. Okay. So 4, 1. X is 4, y is 1. 2, 2. And then 1, 4. Take a look at those points. Those points give us a curve like this. And then the other 4 points, -1, -4, -2, -2, and -4, -1, give us a similar curve like that. This kind of a graph is called a hyperbola. And if you are analyzing if it's linear or nonlinear, well, it curves, so it's clearly nonlinear. But as far as the vertical line test goes, each one of these does touch only once. So it is a function. It is a function. So it's nonlinear, but it is a function. It kind of looks like the graph, like right here, it kind of looks like it's going straight down. And then right here, it kind of looks like it's going straight up. It's really not, though, because if you plugged in those values, they're moving over a tiny bit each time. And what's kind of cool about this kind of a graph is it never touches either axis. It never touches the x or y axis. It just gets closer and closer and closer, but never touches. Okay, our next graph, this is absolute value. So I think you can do this one without a lot of difficulty. So if you plug it in, the absolute value of 2 is 2, and so on. You can graph this one. The next one has an exponent, and you can use the regular 5 on this one. So if you plug it in, 2 to the second power is 4. And I'm going to go way down here to the bottom. If you put this in your calculator, 2 to the power of, like you can use an XY power key or maybe YX power key on your calculator to put that in. This will actually show you that it's 1 over 2 to the second, or 1/4. Or if you convert it to a decimal, 0.25. Okay? So just so that you make sure that you're plugging those in correctly. X to the third power, so regular numbers. We'll work on this one again. So you can plug in 2 to the third power is 8. Make sure that you use parentheses when you put it into your calculator, or you can put it in as -2 times -2 times -2, or you can multiply that in your head even. The square root. On this one, you cannot take the square root of a negative number, so you want to go with numbers that are perfect squares. We'll talk about those more in chapter 10, but perfect squares are numbers like 1, 4, and 9. So we're only going to go with 4 on this one because the next perfect square would be 16, and that would be too big to graph. We want to keep our graphs kind of small. 1/2, if you're taking half of a number, we want all of these values to be even, to take half of a number. So let's go with 4, 2, 0, -2, and -4. So half x plus 3, here's what I'm talking about. Half times 4 plus 3. Half of 4 is 2. 2 plus 3 is 5, like that. So multiplying a number by 1/2 means taking half of it. All right, now this is a click and drag that we'll do in class, and we'll do this one in class quite a few times over the year. So I'm not going to show you what the answers are right now, but you want to just think about, from looking at the graphs first, you should be able to place them linear, nonlinear, and then looking at the equations and all of the things that we just saw on those 8 problems that we graphed for this homework assignment, you should be able to pick out some of these equations and some of the things that cause the equation to create a graph that's not linear. You should be able to write a summary explaining the answer to our essential question for the day, and then our homework is the graphing worksheet. And we've already gotten a start on every problem in this lesson.